Okay, today we're going to use some deductive reasoning. Now let's think about this problem. An auto mechanic knows that if a car has a dead battery, the car will not start. A mechanic begins work on a car and finds the battery is dead. What kind of conclusion could he make? He could come up with a lot of things. He could say that, the car needs a new battery? Maybe after he gets the battery put in, then he discovers that it needs, a new alternator. Maybe the car is a stick shift, and maybe he's got to push the car a little bit and pop the clutch to get it to start. There's lots of conclusions he can come to, but without a doubt, he could say that the battery is dead. The big conclusion would be the car will not start. Okay, that's the big picture. That's the big conclusion that he could come to. So we use reasoning a lot and we make conclusions a lot in our heads every day. But we don't we don't think about how we always come to those conclusions. So today we're actually going to learn two different laws that will help us to come to an accurate conclusion. So deductive reasoning is all about using reasoning to draw conclusions from facts, definitions, and properties. There are going to be two laws that we use in geometry. The first one, let me change to, let's go with green. The first one is Law of Detachment. That's the first one I'm going to talk about. A lot of the times I'll refer to it as LOD because Law of Detachment is a lot to write out sometimes. So we're going to go back to our symbols and we're going to say P implies Q and that is a true statement. And then the statement will repeat P is given. And then these three dots mean therefore. We could say Q is true. Now, that's not making any sense to you right now, I know. But let's look at an example, and through the example, you'll understand what I'm saying. So, if a road is icy, then driving conditions are hazardous. Okay, so there's our P implying Q. That's our original statement. And now I've got another statement here. The road is icy. So, I'm repeating the P again. So I've said P implies Q, then P is given to me again. And what I want you to get into the habit of doing is to mark out the pieces of information that repeat. You mark out the pieces of information that are repeated, and then you have your conclusion, you have your answer. So our conclusion is driving conditions are hazardous. So that's Law of Detachment. P implies Q. It restates P. So then you can say Q is true. The other one, and let's go with purple. All right, our Law of Syllogism. Law of Syllogism. And guess what I sometimes call it? Yep, you got it, LOS. This is going to follow the pattern that P implies Q. So that's going to be one statement. And then you're going to have Q implying R. So the Q will lead you to another statement. And this lets you make the conclusion that P implies R. So we're going to do the same thing. We're going to read through these statements, and when these statements are repeated, we are going to mark them out. If the daily high temperature is 32 degrees or less, that's going to be a P. Then the water pipes are frozen. That would be a Q. If the water pipes are frozen, all right, that's going to be a Q, and that's going to be repeated, so we're marking it out. Then the pipe will break. That would be my R. So I'm going to take the P and the R and make a complete sentence or a complete conclusion, putting those two together. If the daily high temperature is 32 degrees or less, then the pipe will break. So there's my P implying R. Mark out what repeats, and you won't have a problem figuring these out. What's the big deal about this? Why is this important? We want to make accurate conclusions. What's the point of having an accurate conclusion? We want to win an argument, okay? So, a couple of special notes I want to remind you of. Contrapositives. Oh, what's my pen doing? Contrapositives are always true, no matter what. After marking up your sentences with the P's and the Q's and marking things out that are repeating, if you get something that doesn't make any sense and it's not possible, then you have the right to reject the hypothesis, or you can have no conclusion. All right, so you can come up with a no conclusion. So here's how you would see it in the book. The law of detachment: if P implies Q is a true statement and P is true, then Q is going to be true. And the law of syllogism just says if P implies Q and Q implies R, and both P, Q, and R are true statements, then P implying R is also a true statement. So, let's see our examples. We want to be specific. As specific as we can be when we make these conclusions. All right, first example. If you wash the cotton t-shirt in hot water, well, that first part's P automatically without any questions, then it will shrink. That's automatically a Q. So if you wash the cotton t-shirt in hot water, then it will shrink. You wash the cotton t-shirt. Well, that sounds a lot like P, right? Isn't that repeating? So when I have a P implies Q, and then P repeats, which law was that? Yep, that was the law of detachment. So the conclusion you can make is the t-shirt is going to shrink. Will shrink. Now, in this case, if you had said, then it will shrink, that's not being specific. We could specifically say the t-shirt will shrink. Example 2. If you make straight A's, then you can get into UNC. Samantha makes straight A's. So, if you make straight A's, P, then you can get into UNC. Q. Samantha makes straight A's. Well, let's think about this. Our first part doesn't really talk about Samantha. It just says you. However, it is talking about making straight A's. So I feel like that is enough of a restatement of P that we could call it that. So again, Law of Detachment, our conclusion. What is our conclusion? This one we can be specific on as well. Samantha can get into UNC. All right? We would mark this out. We would mark this out. Samantha's pretty specific. All right, next example. If you are a great baseball player, then you play for the Grasshoppers. Angel is a great baseball player. All right, this sounds a lot like the sentence we just did. So, great baseball player, great baseball player. So, LOD again. And this time, specifically, we could say, Angel plays for the Grasshoppers. That's my conclusion. Example 4. All right. If you want to do well in school, then you must study at least 1 hour each night. Susie studies 2 hours each night. If you want to do well in school, then you must study at least 1 hour each night. Susie studies 2 hours each night. So I've got a P implies Q. And then I've got, like, Susie studies 2 hours each night. Well, 2 hours is more than at least 1 hour. So that's kind of like another Q. I can't mark anything out. So if I marked anything out, I could say study at least 1 hour and 2 hours. That's kind of the same, but I don't know. This one, I'm not, like, nothing's jumping out at me on this one. So this one would be a no conclusion. And that's kind of what's going to happen. You're going to go through this thought process where nothing's really repeating. It's not really making any kind of sense to you. And so when that happens, then it's a no conclusion. Our last example is a little bit tricky. If you study biology, P, then you study science, Q. If you study botany, okay, botany, that's something completely different. That's not a P or a Q. Then you study biology. Well, let's study biology is another P. Now, I had an example. My LOS was like this. P implies Q. Q implies R. P implies R. We haven't done a direct example where it shows that one. But I could throw an R in. So let's put an R there. So now let's see what I've got going on. If you study biology, I mark that out. Study biology down here. So what am I left with? Then you study science if you study botany. So if I said it like this, if you study botany, then you study science. So that's an example of how instead of going from P to Q and Q to R, P to R, what I actually did is went P to Q, R to P. And if you notice, see how those Q's are across from each other? And over here, see how these two P's kind of cross each other out? And I'm left with an R on the left-hand side and a Q on the right-hand side. So I've actually used the law of syllogism, but the order's been just a little bit different. And you will have some problems like that.